Welcome to another video with Mr. Longo, and this one is going to cover complex numbers. So complex numbers is a group of numbers that includes all real and imaginary numbers. So you're probably wondering, what is an imaginary number? Well, for the first time ever, you're going to be allowed to take the square root of a negative. This is how. Square root of 25 we know is 5. So what's the square root of negative 25? Until now, it's always been, you can't do it, so not possible or no solution. But now the answer is 5i, where the I stands for imaginary numbers. So let's kind of show you where that comes from. We know that everything squared is positive. So a positive 3 squared is equal to 9. A negative 3 squared is also equal to 9. But 3i squared... 3 squared is 9, but I squared is a negative 1. So 3i squared is actually a negative 9. And that's because if you square root a negative and get I, that means I squared is equal to a negative 1. Okay, so now we're going to be able to do some solving with imaginary numbers. So let's talk about how we work with them. When you work with imaginary numbers, you treat it in a way like a variable, but you have to remember that it's also a number. So when you're just adding and subtracting, it's just like combining like terms. So you have 4 plus 2, that would give you 6, and 3i plus a negative 2i would give you just plus 1i. So when you're adding and subtracting, that part does not change much. Same with this next example. We have 2 minus 4, which is a negative 2, and 5i minus a negative I is going to turn into 6i. And notice that I am writing it with the real number first and then your imaginary number. That is standard form when you are working with complex numbers. Okay? But when you start multiplying, that's where things change a little bit. So to distribute a 2i inside, we're going to have 2i times 3 is 6i, plus 2i times 4i is 8i squared. And that's the part you need to remember, that I squared is always a negative 1. So that technically becomes 6i minus 8. So again, make sure we always write our answers in standard form, where your real number comes first and your imaginary comes second. Okay, but that's the trick right there. You have to remember that I squared is equal to a negative 1, just like we talked about earlier. Okay, so why don't you pause the video and try multiplying, or if you use the term FOIL, these two right here. Pause the video and give it a try. So you would have done 2 times 3, which is 6. And then 2 times a negative I, which is a negative 2i. 5i times 3 is a 15i. And negative I times a positive 5i is a negative 5i squared. So we can combine our like terms in the middle, and we have 13i. So we have 6 minus 13i. And this, you have to remember, I squared is a negative 1, so negative 5 times a negative 1 is plus 5. So your final answer would be 11 minus 13i. Okay? So that's how you do a little bit of work with adding, subtracting, and multiplying. Now, when you are dividing, you have to follow some old rules, and these rules come from working with radicals. If you remember back in the day, you learned that you are not allowed to divide by a radical, or shall we say, have a radical in the denominator. Well, we're not allowed to have an imaginary number in the denominator either. So, in order to get rid of an I in the denominator here, we just have to multiply the top and bottom by an I. Okay, so that's just going to give us 4i over 2i squared. And that, of course, is going to be negative 2. So we have 4i over negative 2, which just means we have the answer is negative 2i. Okay, so that part is not that difficult. But when you have a plus or a minus sign in between, you have to multiply the top and bottom by what's known as the complex conjugate. So really, you're multiplying the top and bottom by the same 2 and I. The only difference is you have to change the sign in the middle. So you're going to multiply the top by 2 minus I instead of 2 plus I. Okay, and when you do that, when you multiply the denominator, the I will go away. See, if you multiply it by 2 plus I, you would end up with 4 plus 4I plus I squared. And that doesn't get rid of the I. But when you multiply something by its conjugate, the positive 2I and negative 2I are going to cancel each other out, and the I does go away. Okay, so the top you just distribute. 3 times 2 is 6, minus 3 times I is 3I. Over. Now you're going to have your multiplying. 2 times 2 is 4. 2 times a negative I is a negative 2I. And 2 times a positive I is a positive 2I. And then I times a negative I is a negative I squared. Again, these guys in the middle are going to cancel. That's why we use the conjugate. But a negative I squared is a plus 1. So that's going to give us 6 minus 3I over 4 plus 1 is 5. Okay? So that's how you work with a complex conjugate. So why don't you work with these two? See if you can simplify these two on your own by multiplying the top and bottom by the conjugate. As soon as you're ready, click play and we'll see how you did. So this one you would have multiplied the top and bottom by 2 minus the square root of 3. Again, you cannot have square roots in the denominator. The top part is easy. You're going to have 8 minus 4 square root of 3 over. And when you multiplied this on the bottom, you're going to have 2 times 2 is 4. Your 2 times the negative square root of 3 and your 2 times the square root of 3 would have canceled. And then you would have been left with minus the square root of 9. And we know that the square root of 9 is 3, so this is technically 4 minus 3, so your final answer would be 8 minus 4 root 3 over 1. So you could have just left it as 8 minus 4 root 3. And the last one, you would have multiplied the top by 3 plus 2I. And again, if we did that, the top we would have 6, and then you would have to multiply the 2 times the 2I would be a 4I, 3I times 3 is a 9I, and 3I times 2I is a 6I squared. All over, we would have to multiply the bottom, we would have 9. Remember, our negative 2I and 3 is going to cancel out the positive 3 and positive 2I. So that's going to go away, and then you would have negative 4I squared. So when you fix the top, you have your 4I plus 9I, which we know is 13I. But 6 and a 6I squared is going to cancel. Because remember, I squared is a negative 1, so 6I squared is negative 6, plus 6 goes away. And then on the bottom, I squared is a negative 1, so this is technically a plus 4, so you're going to have 9 plus 4, which is 13. Those would cancel, and all of that simplifies to just I. Okay, so that's it for this video on complex numbers. Now that you know how to work with complex numbers, we're going to go solve with complex numbers. So this is Longo, and I'm out. See you, bye.